Hello, everybody. This is Coach Roswell here. In this video, we will go ahead and discuss logic, and it will be the total review of the whole entire unit. Okay, so ideally, what we're working with here is we're working with inductive reasoning in the recognition of patterns. And if we're trying to use an inductive reasoning to find a pattern within the table, then ideally we're going to be using y is equal to mx plus b, which initially is point slope form. Now, if you happen to go and forget this, obviously you can go back to my previous videos where we discussed this. What we're going to do here is that we're going to identify what's going to be the pattern between 6 to 8. So I have terms 4, 12, and 20. So that's the term number I'm at. So from 6 to 8, we're going to go plus 2. From 8 to 10, we're going to go plus 2. So I'm going to change in y. I'm changing x. So actually, let's go. My change in y will be plus 2. And if I am looking for going from 4 to 12, that's a plus 8 and plus 8. So that means my change in x will be plus 8. Now, if I go ahead and reduce this, it's 1 over 4. So that's going to be my slope. Now, ideally, this part right here can be recognized as your pattern that we can see from the table. So the first part of the equation is y is equal to 1/4 x, and then plus we have y-intercept. So in this case, it would be the b. So if we're looking for, let's use a different color. If we're trying to look for b, then that means I'm going to use y is equal to mx plus b, and I'm going to plug in what I know. So I know that m is 1/4, and my x and y, I can pick whatever I want in terms of the points. So I can pick the most easiest points to be x and then to be y. So I have my y, which would be 6, and then my x would be 4, and then plus b. Now from here, 1/4 times 4 is going to give you just simply 1. And then subtract 1 on both sides. And then you get b is equal to 5. Okay, so there you go. Now you have plus 5. So now you have your equation that you can go ahead and build from it. Okay, so and make sure you check out the other videos too. I'll cover this majority of it. So you can also make inductive reasoning with use inductive reasoning with tables. All you have to go ahead and understand is that you need to understand that you got to use point slope form, and you have to go ahead and build that equation if you're given that table. Okay, and then this initially here would be the pattern that we're using. Okay, slope's just a part of it. Okay, so let's keep going on. Okay, so going through these. Now, these are ideally the same, except they look like blocks. So we want to label which one's my first one, second one, and third. So my first, my second, my third. So it's first, second, and third. Okay. Now, the next part you want to do is you want to count how many blocks you have to work with. So 1, 2, 3, 4, 5. So I have 5 here. So 5 goes inside here. 1, 2, 3, 4, 5, 6, 7. So I got 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9. Now, some of you may have already seen a pattern, but you have to be able to identify the first difference on each one. So if you remember, the first difference was between each term. So whether it's the x or the y, though when you subtract them, then you'll see what you would have. Okay, kind of how we just did over here. My first difference in number 1 was when I have my first difference for the y's would be plus 2. My first difference for the x's would be plus 8. Okay, so those are ideally your first differences. So first difference. First difference. So you know what I'm referencing every single time. Okay, let's keep going. All right, so a counterexample is ideally just a false example of the statement that you're given. So for number one, for number nine. For number nine, I mean, all Springwoods High School's teachers are female. So that would be considered false because I am male. So Coach Razzo is male. Okay, and then you can use other examples along the way there. Okay, so just come up with an example when it will be false. Okay. Like for number 14 is also another example. So all iPhones are Android. Is that true or false? That's false because why? Because you have iPhones. Okay, so you have those to go ahead and use. Now, next part. Conditional, converse, inverse, and contrapositive. So I'm going to use letter P's and Q's to go ahead and see what we have. So remember, P, if P, then Q. Okay, so remember that the P was your if, this is your then. Converse, flip it. So we have Q, and then we have P. So if Q, then P. Use a different color. This is gray. So my inverse is that I'm taking the negation. So I'm going to negate. So this part, that represents negation, which can go ahead and become a not. Okay, so make it a little bit simple. So not P, then not Q. Okay, so not. So if, and that's your then. Now my contrapositive is that I'm going to take the not of whatever this is. So the not of that, and I'm going to take the not of my converse. So if it is not Q, then it is not P. Okay, so tilde and tilde. Okay, so let's go work on a few of these. So if I go and say, I will win the game if my team scores another point. So that means my label the hypothesis and conclusion. So I'm going to label my hypothesis with a highlighter. So my hypothesis will be anything after if. So if I'm looking at number 16, if my team scores another point, so this is going to be my my hypothesis. Okay. Then the conclusion, which is Q, is going to come anything after. Anything that's remaining will be the then. So I will win the game. Okay? So there you go. So here's my hypothesis, which is P, and here's my conclusion, which is Q. Okay? So just be careful when you're solving these. Hello everybody, it's Coach Razzo here. So in this video, we'll go ahead and discuss how to go ahead and find the conditional, converse, inverse, and contrapositive and determine whether it's a true value or not. Now, this also involves the drawing the counter example, so if any. So if you need a couple examples of these, then you're more than happy to tag along. Okay, so for number 19 from the review, then one way to go into consider this is that we have to be able to turn the statement that we're given into a conditional, and that let's just go ahead and figure out this situation over here. So is it P then Q, or if Q then P for converse, or if not P then not Q for the inverse, and then for the contrapositive it was if not Q then not P, so which is going to be the not of the converse. So if you're a little bit confused on those, just make sure you go ahead and check out the previous examples. So as we're going through this, we have to go ahead and rewrite this in terms of if and then. So if and then form. So we're going to start from the beginning. So simple straight angle sum to 180. So we're going to take whatever we have in the beginning. So we're going to cut it. So if there's so if and then you have then, Now, if you're trying to piece these together, um, let's go ahead and write it out. So if two angles are supplementary, then they sum to 180. Okay, so there might be some characters out there where they read it a little bit different, where they may have that backwards. So just be aware that you wouldn't want to go ahead and break up the just break up the statement as you see it, and then you have your if and then. Now, so that being said, if we're going to have to match up with whatever we have from here. So if two angles are supplementary, so that's not it. If two angles are 180, that's not it. And then if two angles are not supplementary, that's not it. So that means my last part here would go ahead and be my conditional. My conditional. So that means that I have just eliminated this one right here. Okay, so now I have these left over. Now the truth value, I want you to be able to draw these on your own. And if you can't draw it, that means you need to get a little bit more practice on how to draw these. So if two angles are supplementary, then they sum to 180. So we're going to come up with examples where we're going to draw supplementary type of angles. So one example, let's see, one example you can have is that you can have an example where it's 100 degrees, and that can go ahead and be 80. And so they're supplementary because they're add up to 180. And then we have this example over here where it is 100 degrees and that can be 80. So these two examples are supplementary and they both add up to 180. So that means that these will be considered to be true. So these are just examples of a true statement. So true, and that is true. So I'll be drawing examples so you can go ahead and follow along. Okay, so next part. If we're trying to find the converse, I want to go ahead and flip whatever I have. So if this was my if in the beginning, and then that was my then, I want to flip those yellow and blue, just flip them. So that means my sum has to be in the beginning. So if two angles sum to 180, which is this one right here, then they are supplementary. So that's going to be my converse where they got flipped. Okay, so in this one, I'm going to go ahead and draw whatever I got. So sum to 180. Just a minute. Let me just go ahead and move this one. Okay, I got a little more space. Okay, so sum to 180, then they're supplementary. So I'm going to draw examples where they add up to 180. So here, it's 90. I'm going to draw this one over here. That's going to be 90 as well. And then I'll draw, let's draw something different. Let's draw it this way. And I'm saying that's 45. And I'm saying that's going to be 135. Okay, so we have these two examples. So if two angles sum to 180, then they're supplementary. So I have these two types of angles that I just drew. This one adds up to 180, and this one also adds up to 180. So that means they're supplementary because they still follow the same criteria from the previous red example. So that means this is considered to be true. Okay. Now, some you may have noticed this part right here, where both the converse and conditional are true, and that'll be considered biconditional, which means if and only if. So this is just saying where if you have if you have a statement and you find that the hypothesis and the conclusion are both true when they're in conditional and also when they are converse, that means you can use this phrase to go ahead and combine it, and that will let you know immediately that it's biconditional. So if we're trying to go ahead and figure this one out, so that means that, oh, if all true. So we'll just keep going through it, okay, for now. Yeah, we jumped the gun there. Okay. So this is my conditional have. I know if all true, then we got to figure it and find that part out. Okay, so let's take the not of the conditional. So if the two angles are supplementary, we can change it to a not. We can put a not in there. So if two angles are not supplementary, so which is two angles are not supplementary, then they do not add up to 180. So that means this is going to be my inverse. And remember, the inverse was where that's P, that's Q. You're just taking the not, which is a little tilde, in front of the P and Q. Okay, so from here, we're going to see if we can figure out. So if two angles are not supplementary, they do not add up to 180. So we're going to come up with another example. So it's all about drawing. So you can go ahead and create your counterexample. Okay, so if two angles are not supplementary, so I'm going to make up one where they will not add up to 180. Okay, so I have, so here, I'm going to say that's 100. And I'm going to say that's going to be 30. Okay, and they add up to 130. So that's going to be not, they're not going to be supplementary. Okay, so I have another example. I'm going to use 100 again. And then let's say I use the value of 20. And so that's going to be add up to 120. So that means these angles are not supplementary because they, let's see. Let me see. I'll go ahead and connect this one right there. 120. So that's going to be 20 degrees. So that would be 20 degrees plus 100 gives you 120. That's going to be separated. So it'll be 100 plus 130. And that gives you one. No, so 100 plus 30 gives you 130. Now, if we go ahead and say that they are not supplementary, which is based on these two facts, then they do not add up to 180. So that would be considered true and true. So this is my true, and this is my true. So ideally, this will be true right here. Okay. So we're trying to give examples. We're drawing examples for each, so we can go ahead and see if we can come up with like a false statement. So drawing's really key here. Next part. So truth value. If last one's actually going to be contrapositive, because we just eliminated our inverse. So I have contrapositive. Now the reason it's contrapositive is we're taking the not. We're taking the not of Q, and we're taking the not of P. So we're taking the not of the converse. Okay, because this is my Q and this is my P here. Okay, so from here, if they do not add up to 180, then they are not supplementary. So if I come up with like 45, and I come up with another 45. 45, that means they add up to 90, not 180. And we're going to use the same example. Okay, because, and then we're going to have them connect and they'll be adjacent. This will be equal to 90. So they do not add up to 180, but they are not supplementary. So that we consider true in this case, because we just proved this to be right. So you got to be creative in this way where you have to come up with your own examples. So by conditional, what do we go ahead and be? So if two angles are supplementary, if and only if, let's see, the sum is equal to 180. Okay, so there's your biconditional for you to go ahead and say that it's true whenever you have the converse and conditional to be true, and then you can go ahead and flip flop it. It will give you the same scenario. It will not be something different. Okay, so be careful. Make sure you go ahead and come up with the, and if you notice down here, you have pictures. And just make sure you go ahead and come up with an example of when can be considered false. So one of these have to be labeled as false. So we can go ahead and so we can go ahead and label it, go ahead and pick one of those counter examples, okay? So keep practicing, guys, okay? Now, next part. Write the conditional and draw a diagram for the statements. We may have seen this one actually. So from here, Tuesday is a weekend, so weekday. So I'm gonna go and break it up. I'm gonna break it up. Let's find the spot. Not the manual one. Break it up right here. So if it is Tuesday, then it is a weekday. So there you go. Now don't forget, when you have these, your P is consumed by the Q. So the hypothesis is part of the conclusion. So here it'll be Tuesday, and it'll be a weekday. Okay? So just giving you a heads up for the Venn diagrams.